So in this video I'm going to explain the solution of educational code forces around 5, 8 rated for division 2. So in this video I'm going to explain the first three problems and their intuition and their solution. So let's start from problem A. The name of the problem A is line trip. So I will tell you a solution of a problem here only. So for example, I am at position 0 and there are some number of gas stations in between some points. So what are the gas station? Gas station is defined as array 1. So this is A1, this is A2, this is A3 and so on. So at then what I have to do, I have to reach from point 0 to point x, right? I have to again come back from x to 0 also, right? So they have given a gas fuel capacity named as gas, right? So if I want to go from point 0 to point A1, then the amount of gas required will be equal to A1 minus 0, which is indeed A1 only. So if I want to go from point A1 to A2, then the amount of gas required will be A2 minus A1. Okay, right. So what they have said, that our car will have some quantity of gas which can be filled into it at most one time, which means if initially I have a gas capacity of x unit, then I cannot fit more than x unit in my gas, right? Or they have also said one thing, that if I reach at any gas station, then whether what is the state of my gas tank, I will simply refuel to it x only, which means to its maximum capacity. So they are only asking the value of this x only, that what could be the maximum, what could be the minimum capacity of my gas tank, such that I can go from this point to this point and again reach back to from this point to this point only, right? So I have to the I have to I so I think so the problem solution is pretty much intuitive, right? Why? Because you can see my answer is always, because you see I have to go from this point to this point, this point to this point, again this to this, and at the end there's some station as this, that I have to go from this position to this position. But you can see there is no gas station at point X, which means I have to again come back from this position to this position, right? So the maximum of all these will be my answer, right? Okay. So you can see what is my answer. My answer is the difference between 0 and A1. Maximum difference between A1 minus 0, A2 minus A1. And similarly, if I am at my last position, then I will simply check it also, that 2 into an minus x, right? So the maximum of all these answer will be the capacity of my gas tank. So if I show you the code, so simply what I'm taking, I'm simply making my input array and simply appending 0 in the start and x in the end. Similarly, what I'm doing, I'm simply calculating the difference between the adjacent numbers and storing the maximum from it. But you see, but for the last position, I have to also come back from I have to also come back at this position, which means for this case my answer will be multiplied by 2. This is the last number, which is x only, and simply multiplied by my second last number, which is a of n. The maximum of all this will be my answer, and simply print. So this is the problem A solution. So this is pretty much easy. So now let us begin to the problem B. So this is a problem B. So I will explain it question here only, right? So you see, the what problem is asking us to do right here is, for example, we are given a ribbon of n size, which means there are some n partition in this ribbon. Okay, and what they have said, that we have initially a chip, and we will place chip at index 0, or you can say index 1 from 1 base indexing. You can see they are now telling us I can perform two type of operation on this chip. What are two type of operation? The first operation is defined as that I can simply place a chip into its next position. For example, if my chip is at index 1, I will simply put the chip at index 2, and here there will be no chip, right? Or there also said the value of my nth part of the ribbon. So the value of ith part of my ribbon will be equal to the number of times a chip had been at this position, right? So you can see the value of position will be equal to 1, but the value of position 2 now will be equal to 1, but value of position 3 is equal to 0, because the chip had not been any number of time at position 3. But you can see if I place chip from this position to this position, then you can see this value will also become equal to 1. So this is the number 1 operation. Then what is the number 2 operation? Number two operation is defined as that if I am having a chip at any position. For example, in this case, you can see if I am having my chip at this position, I can simply pick this chip here and place it anywhere in my array. Indeed, at this position also I can place it, right? So if I pick chip from this position and place it at this position, then the value of this will be plus one, right? The original times plus one, right? Okay. So this is how the two operations are defined. Now what they have said that now what they are telling us to do is like initially we they are giving us a array, and what they are telling us to do simply, for example, in this array is this, and what they are telling us to do, I have to tell them what is the minimum number of operation or minimum number of teleportation. You can see if I'm placing chip from here to here, there is no teleportation. Here it is just increasing index. This is zero cost operation. But if I am placing this chip anywhere else and from this position in the array, then it will cost me one unit, or you can say it will cost me one cost, right? So I have to tell them what is the minimum number of costs such that this configuration is achieved in my ribbon. Okay. For example, I will debug this test case. Here you can see my answer is 1. Why so? So you can see first initially my chip will be here, then the position, then the answer, then the value will be here 1. Then I will place it here, then it is also 1. Then I will place it here, then this is also become 1. Then I will place it here, then it will also become 1. Which means at most one times the chip had been at all the position, right? Okay. But now you can see but the condition is still not satisfied, and my chip is at here. You can see if I teleport this chip to this position, okay, I have teleported it. You can see the chip had been once in this position, so I will simply increase it to 2 only, right? So if I use the first operation on this index, which means I will put the chip from here to here, right? You can see this will also increase to 1, right? Here you can see my configuration is chip, which is 1 2 2 1, and here you can see how many times I have to teleport my chip. I have only once teleported my chip, so here answer will be 1, right? So this is a example of this. So what is the generalized solution for this, right? So generalized solution will be it is also easy, right? Okay, you can see if I'm having some configuration like x, y, and z, right? And you can see in the first chance I will place my chip here only because they have given. First of all, I will place my chip at first position only. It is a rule, right? You can see chip at first position of the ribbon. You can see I will simply place my chip here. You can see I cannot return back here any of the times. You can see if I'm at this position, if I'm having a chip at this position and I place it here, place it here, place it here, place it here, there is no such operation from which in no cost I can increase this value. Which means to increase this value, I have to use teleportation. Teleportation. There is no other way in which I can increase my first number. So you can see the number which is at my first position is the number of times my teleportation is required to make this number. For example, you can see if I having 2 at first position and here is 1 1, right? So simply I will simply place first time chip here, then place it here, then place it here. You can see now I cannot increase to 2 without using a single operation. So I will simply use an operation and place it chip here once again. Then this value becomes equal to 2 and there is 1 only. So simply this is a one part of the solution, which means I will simply add array of 0 minus 1 in my answer. So okay, right. What's next? So this is the first observation. I will simply add array of 0 minus 1 in my answer. But for the next positions, okay. For the next position, I will also see. So you can see if I'm having a configuration like this 1 2 3 4 5. Okay, it is simple. So what I can do, I will simply once place a chip at, okay. I will simply, so 1 2 3 4, right. I will simply place one chip here, one set here, one set here, here and here also, right. So now what I can do, I can simply I can simply grab the chip and teleport to at this position, right? If I'm teleport to this position, then when this value will be increased to 2 only, and these are all satisfied ones only. You can see, and by placing it here, this will be always set also be satisfied, right? Then I will simply place it from here to here, then here to here. Here you can see my only requirement left is here it is one left and here it is two left. Then what I will do, I will simply teleport from this position to back to this position here only. Then it will become 0. Here you can see if I am at this position, I will simply place it at this position again. So then when this will become equal to 1, and here you can see my 1 is also remain. So how to increase this one? So I will simply add this into this only, and you can see teleport from this place to this only. You can see that this also be satisfied. But you say there is no general solution in this. This is only I will do this, I will do this, but there is no general solution coming up. So you can see that the general solution is pretty much easy. So if you see, if I'm having a ribbon like this, and here it is position x, and here it is requirement x, and here it is requirement y, and you can see my requirement x is smaller than my requirement y. Okay, which means if my chip is at position x, I will simply place it to position y. Okay, right. So now to increase position y, I have to again use a teleportation, right? I cannot increase my y again. Okay, so this is the only general solution, which means to increase it y, I'm always required x. Okay, rather say I can say y is greater than x, y minus x times of operation to make this possible. Okay, so this is our problem solution. If I show the code is where it is. Right, here is the code. So simply what I will do, I will simply add the first index minus 1 in my answer because it is a requirement. You can see to make this 2 possible, there is no another operation in which I can increase this 2. So I will simply plus the answer of array of 0 minus 1 in my answer. Right. Then moving on the next, if my next value is greater than my previous value, I will simply add the difference between them and simply print my answer. So this is our problem intuition, right? Okay, now let's now become to the last problem which I have solved. It is a problem C. So this problem is pretty much interesting. You know why? Because I have got some pretty much wrong submission on the problem, then got a right answer. So what problem said that we will be given an integer array A. Okay, and what I can do in a single operation is that I can choose any number x and add that number x into every number in my array. Okay, then after adding x into every number of the array, I will simply divide that number by 2. Okay. Then after dividing it by 2, I have to tell how many times I can perform an operation on this array such that all the elements in the array become equal. Okay. For example, you can see here it is only one index. Then my answer is 0 only. But you can see here it is 4 and 6. Okay. If I show it here only, so if I show it here only, okay. Here it is 2, 4 and 6. Okay. So in the first operation, I will simply add 2. So if I am adding 2 in my array, then my array will become like 6 and 8. And dividing it by 2 will be looking like 3 comma 4. But they are not equal. So what is the second operation? Second operation is adding 6. So if I add 6 in the both of these, then my what is my array looking like? So if I adding 6, here it will become 9, here it is become 10. Then dividing both of the numbers by 2, it will give me 4. Wait a minute. Right. I have to add 5. Okay. I have incremented the wrong number. So right, you can see if I add 5 in the both of these number, this number will become equal to 8 and this number will become equal to 9. And dividing both of the number by 2, this will become 4 and this will also become 4. But you can see divisible, the, the divisible part is always floor only. You can see this equation. So it is only for floor fraction. Okay, so what I have to tell what is the minimum number of operations required to make all the numbers equal. So I will tell you the intuition behind the right solution of this problem. So you can see, if I'm having some arbitrary array, or there are some random points in the array. For example, here it is 3 2. I'm simply taking a random number only, 5, and here it is 6. So first of all, I will calculate the minimum and the maximum point in the array. Okay, so the minimum number is 2 and the maximum number is 6, right? Okay, so what I am trying to do is, right, I will not change my minimum number after any operation, which means after performing an operation, my minimum number should not be changed at any time. So what number I should add in my minimum number? So you can see what number I should add in my minimum number, such that dividing it by 2 give me only this number, which is 2 only. You can see, or I can say in x terms only, right? So what number I should add in x? Okay, right. So what number I should add in x, such that dividing it by 2 give me x only. By solving this equation, you can see it will came out to x only, right? Which means in minimum number I should add minimum number once again, and dividing it by 2 give me minimum number only. So this will neglect the operation value, effect of operation, you can say, which means I will simply add the minimum value itself, will do the minimum value in every operation and divide it by 2, and this will not affect my minimum value, right? So but what is the role of maximum value? I have to make this maximum value equal to this position only, or I can say I have to decrease this value to this point only. Okay, so this is the pretty much easy. So first of all, what I will do, I will calculate the difference between both of them, right? For example, if my minimum is I and my maximum is x, right? So I will never change my minimum value at any cost, or at any operation. Okay, which means my minimum number is not decreasing at all. I have to tell you, I have tell that how you can neglect the operation. I will simply add the plus I and divide by 2 at every operation. So which means my minimum value is not decreasing, which also means I have to make this value equal to this value in this difference. So first of all, what I will do, I will simply calculate the difference between the maximum and minimum value, which means my difference is maximum value minus my minimum value. Okay, so by calculating difference, which means I have to neglect this difference. How can I neglect this difference? Simply, you can see there is a pretty much simple loop I am using. If I show you the code, if I show you the code, you can see I will simply checking like this only, right? So what is my minimum value? I have to make this maximum value equal to this value. So I will simply decrease my maximum value to minimum value. So what is the operation? Here you can see what operation I am using at every time. So I have to tell you, I will only use a minimum value as my x at every point. So what means I have to make my maximum value is equal to maximum value plus minimum value divided by 2. Okay, so this will somehow decrease my maximum value. Okay, so by decreasing my maximum value to some extent, I will simply count the number of operation which is required to make the maximum value equal to minimum value. And what is the operation? Operation is simple, or I can say what is the x I'm adding at each time is simply I only. I will simply add I at every point. You can see by adding I at every point, my minimum value is never changing, but my maximum value is decreasing. Here you can see my maximum value is maximum value plus minimum value divided by 2. You can see this value is this value is always be smaller than equal to x only, which is indeed decreasing my maximum value. So simply I will count the number of times I am using this operation to make it equal to minimum value, and I was simply, and what is x? X is always minimum value at every point. So you can see if this is a code. First of all, I'm calculating the minimum and maximum value and simply checking if a minimum and maximum are equal. Then I will simply print 0. Else, you can see what I'm trying to do. I'm simply trying to make my maximum value is equal to minimum value, and what I'm doing is simply adding the minimum value in my maximum value and dividing it by 2 and increasing the number of operation. So if my number of operation is greater than n, I will not print the minimum value. But if my answer is smaller than equal to n, I will tell them then the operation which I'm using was minimum value only, which means my x at every point is minimum value only. So this is the whole permutation. So if you like the video, please don't forget to subscribe my channel. Till then, stay tuned for the next one. Thank you. And if you have any doubts, please comment me down, and please don't forget to subscribe the channel. Thank you.